The universe is an enormous place, with billions of galaxies and trillions of stars and planets within those galaxies. If there are so many planets capable of supporting life, then why haven't we met any aliens? Or, put another way, why don't we see any evidence that other civilizations have existed? This question can be boiled down to two questions. Are we the only civilization capable of sending out signals into space, and are we the only civilization to receive those signals? These questions have given scientists sleepless nights for decades, but we might have found the solutions to these questions. Keep watching to find out the solutions to this paradox. You may have heard of the term Fermi paradox. It all started when Enrico Fermi, back in 1950, mentioned just how odd it was that there was no apparent evidence of alien life. The physicist was having lunch with Edward Teller, Emil Konopinski, and Herbert York at Los Alamos. At one point the conversation touched on a cartoon where aliens were carrying trash cans stolen from New York City. The talk then veered towards the general issue of existence, or otherwise, of extraterrestrial intelligence. While they did not take the flying saucer story seriously, Fermi and his companions earnestly discussed topics such as interstellar, and even superluminal travel. Then, Fermi asked his famous question after some delay. Where, indeed, is everybody? His friends understood that the great physicist was talking about extraterrestrials. In a nutshell, Fermi's reasoning was as follows: both time and space are large in our astronomical environment, but there is an essential sense in which the temporal scale is larger. Our galaxy is about 100,000 light-years from edge to edge according to studies, which means that a star-faring species would need about 10 million years to traverse it if moving at a very modest velocity of just 1% of the speed of light. Since the galaxy is about 1,000 times older than this, any advanced technological civilization will have much more available time for such expansion and colonization of all planetary systems that exist in the Milky Way. If one species fails in this endeavor, another won't. Consequently, if intelligent species were out there in any appreciable numbers, they would have been here already. And yet, we do not see them on Earth or in the solar system. For Fermi and many thinkers since, this constituted a paradox. As all this was happening, one should keep in mind, 7 years before Sputnik 1 and a full 11 years before the first human cosmic flight by Yuri Gagarin, Enrico Fermi, sadly, did not live to witness either of these two epoch-making events for humanity, having died in 1954, only 4 years after his Los Alamos conversation. However, his powerful intuition applied excellently to this case, since he could not see any reason interstellar travel would be impossible, and even if he underestimated the size of the Milky Way, it was at best a factor of a few orders of magnitude. In any case, he found a way to formulate, clearly and memorably, an obvious but still not understood enough fact, that humanity is a new phenomenon on the cosmic scene and that extraterrestrial intelligence, if it exists, is likely to be older than us on the basis of that fact alone. Adding the modern-day values for the age and size of the galaxy and other astrophysical data just strengthens this conclusion and makes it likely that the difference in ages becomes only larger. Before we can look at the solution to this paradox, we need to understand a popular equation known as Drake's equation. 61 years ago, Frank Drake produced an equation to estimate the number of communicating civilizations in our own galaxy. Since then, our knowledge in this area has grown as we discovered exoplanets and became more enlightened about the universe as a whole. We now have a better understanding of the number of stars in our galaxy, star and planet formation, and other solar systems that contain habitable planets. Scientists have learned a lot in 60 years, but they've just scratched the surface. They don't know much about life on other planets, which is why they sometimes talk about intelligent extraterrestrial life. Some scientists said that it's probable that there is life out there somewhere, and not just on Earth. If you think about it, Earth is a really big place for such little probability. It makes sense to believe that intelligent life is common in the universe, but most likely outside of our own solar system because of how far apart planets can be from one another. So, what is the Drake? It's this weird stuff on your screen. Believe me, I had no idea what those letters meant at first either. Let me explain. N is the level of detectable civilizations in the universe. R* is the rate of star formation. Fp is the fraction of the above stars that have planets. Ne is the number of above planets capable of supporting life. FL is the fraction of above planets where life evolves. Phi is the fraction of above life that becomes intelligent. FC is the fraction that develops detectable communication. L is the longevity of communication. Looking at the known star formation rate can be misleading because of the large number of stars in the Milky Way today. Considering that there are approximately 200 to 400 billion stars, the current star formation rate is much different from what it used to be. Let's solve for the number of stars present in our galaxy today instead, with 300 billion being our starting point. In order to do this, we will start at one end of the equation and keep adding up as we work backward. Then we look at the fraction of Sun-like stars. The assumption that red stars are unsuitable for hosting habitable planets is likely a conservative assumption. Today we have a pretty good understanding of this thanks to space observatories like NASA's Kepler. The number of Sun-like stars is approximately 18%, which corresponds to 54 billion stars. The fraction of planets in the habitable zone is assumed to be around 1 to 2 per solar system. If we assume 1 to 5, this leaves us with 81 billion planets in the habitable zone in our Milky Way. The next step is to estimate the number of suitable planets for life, and this is where the complicated work really begins. Life as we know it needs a terrestrial planet that's the right size, with a giant planet like Jupiter protecting it from asteroid impacts, a natural satellite like the Moon to help stabilize its orbit, a magnetic field and tectonic plates for volcanism, and an atmosphere that has the right chemistry. And just because there are some conditions on an Earth-like planet doesn't mean it's habitable. Let's say there are only 20%, we are left with 16 billion planets that can actually support life. Now let's take a look at what fraction of these planets actually develop life. This number is currently unknown, but we know for certain that it has happened on this planet in the past. Life as we know it requires evolutionary forces such as glaciation and meteor impact events, the appearance of the eukaryote cell or similar, sexual reproduction, and many other factors. Looking at Earth gives us evidence that life is inevitable. Considering that we have found no evidence elsewhere suggests the opposite. The first indication of life in our own solar system or on an extraterrestrial planet would drastically increase the probability of life. Let's assume a 50% chance that life will arise as long as the conditions are right. This brings us down to 8 billion life-hosting planets. The next parameter is about intelligent life. It's possible that complex life is common while intelligence and consequently civilizations aren't. Since we don't know the frequency of complex life, then the prospects for intelligent life are uncertain. Is it even necessary from an evolutionary point of view? It took 500 million years on Earth just to create civilizations, and along the way, there have been several mass extinctions that have impacted evolution. This parameter is basically impossible to say anything about, but taking an average from multiple scientists, we will end up with a 20% chance of success. Down to 1.6 billion civilizations in total. How many of these civilizations will develop a technology that potentially can release detectable signals of their existence into space? Intelligent alien species may lack advanced technology. In the history of life on Earth, only one species has developed a civilization that is capable of spaceflight and radio technology. Let's assume 50% and 800 million high-technological civilizations. Extraterrestrial civilizations may choose not to reveal themselves for many reasons. What is the fraction of civilizations that deliberately broadcast detectable signals into space? It is, by the way, a question of the definition of whether Earth can be considered an actively broadcasting civilization. Over the lifetime of a civilization, it is probably difficult to avoid this. 80% would give 640 million actively broadcasting civilizations. If civilization is broadcasting, it will not coexist in time with a sun-like star that has an average lifespan of 10 billion years. The first and last billions of years of life on Earth are not particularly suitable for life to exist on an Earth-like planet. For simplicity, we will assume that the lifetime of any Earth-like planet existing at this moment in the Milky Way is 1 billion years. A civilization that lives for 1 million years has a 0.1% chance of coexisting with us. If a civilization transmits for 10,000 years, however, there is still a 0.001% chance of them living at the same time as ours. This leaves only 6,400 deliberately broadcasting civilizations that live now. So, we can estimate that there are 6,400 actively broadcasting civilizations in our galaxy. That number is almost certainly inaccurate and hard to verify, but it serves as a good example. The main reason for a lower number is the high uncertainty that comes with it. This usually brings down the estimate drastically. But on the other hand, we have already left out, for example, all the red dwarf stars. These stars make up about 75% of all the stars and can live for 100 billion years. Even though there are plenty of other things that could make them unsuitable for life, it is still a very conservative assumption to leave out a star type that is 100 times more common than our own Sun. So, let's keep it at 6400 for the time being. Now, where is everyone? That's the essence of the Fermi paradox. There is no reliable evidence that aliens have visited Earth. We have observed no intelligent extraterrestrial life with current technology, nor has SETI found any transmissions from other civilizations. The universe apart from the Earth seems dead. The Fermi paradox claims that the Earth should have been invaded by technology-wielding life forms because they would be able to detect our radiation. This is especially true considering our oldest radio signals are 100 years out. The thing is, those signals aren't powerful enough to be detected. The first intentional transmission into space was made in 1974, and it was focused in one direction. So there's a very simple explanation for why the Fermi paradox exists: life forms haven't discovered us yet. Over the years, scientists have been able to come up with some solutions to this paradox. One solution is that we're living in a simulated universe. Some of the world's most famous scientists, philosophers, and academics have some pretty far-fetched theories about the nature of reality. These crazy ideas are surprisingly logical and make sense in a way. They've been debated by major academics for years now. In a paper called "Are You Living in a Computer Simulation?" by Oxford philosopher Nick Bostrom, he argues that one of the following three statements must be true. Humans are likely to go extinct before they are post-human and able to create entirely simulated realities. A post-human civilization with the ability to run such a simulation would likely not run many simulations because of the immense amount of resources needed. We are currently living in a computer simulation. Using extremely clever logic and a bit of mathematical fiddling, Nick concludes that the belief that there is a significant chance that we will one day become post-humans who run ancestor simulations is false unless we are currently living in a simulation. Another solution to the Fermi paradox is that aliens are broadcasting, but we don't know how to listen. SETI is counting on this solution. With a little imagination, it's easy to think of a number of reasons why we haven't been able to communicate with aliens. It's possible that aliens use a form of communication with radio waves that are outside the normal range of frequencies monitored by SETI. They might also be able to communicate across the galaxy with neutrinos or lasers. This would be like a galactic internet, complex compression algorithms that we don't understand, gamma-ray bursts that our telescopes can't detect, and modulation methods to which we haven't yet found a solution could exist. In 1985, famous astronomer Carl Sagan came up with an especially compelling reason for why we're missing alien signals. He speculated that aliens may communicate at a rate so slow or fast that we don't even recognize their efforts. If an alien civilization takes years to broadcast a single sentence or even a single word, we do not even recognize that we're being contacted. Another solution to the Fermi paradox is the Great Filter. The Great Filter is the idea that the development of a civilization that can colonize a galaxy is a unique, maybe once-in-a-universe event because of the many exceptional barriers to life along the way. Dr. Robin Hanson, a well-known futurist at George Mason University, published the 9 steps he believes are required to get from a suitable planet to an interstellar civilization, which are: the right star system, reproductive something, simple prokaryotic single-cell life, complex archaea and eukaryotic single-cell life, sexual reproduction, multicell life, tool using animals with big brains, where we are now, colonization explosion. These 9 steps to a colonization explosion are the Great Filter. And the original answer to this paradox is, they are actually Hungarians. After hearing Enrico Fermi utter his now famous paradox, the physicist Leo Szilard immediately answered, they are among us and they call themselves Hungarians. Which is also a complicated answer. Though it may seem impossible to come up with solutions to the paradox, for now, we are alone. Every human is alone when they are born and when they die. This is not so different. If we are the first civilization to arise, then in these formidable years alone, let us use this time to evolve into the best kind of beings. Thanks for watching and consider subscribing to the channel for future interesting videos.